GT 2212 Lab 4 Circuits and Capacitors. Introduction, key ideas, Ohm's law, parallel and series circuits, linearization, quasi-steady states, and RC circuits, resistors, voltmeters, ammeters, capacitors, energy conservation, charge conservation, loop rule, and node rule, series resistors and parallel resistors, just understanding what to do when with current and voltage with series and parallel resistors. And then the loop rule is the sum of the voltages in any closed loop must add up to 0, and the node rule is at any point at any node point, the sum of the currents entering the junction must equal the sum of the currents exiting the junction. You can see that in the diagram. Introduction formula. Ohm's law, loop rule, node rule, formula from the lab for RC and capacitance of a capacitor. Goals of general purpose: predict behaviors of currents containing resistors in series and parallel, use multimeters to measure the actual values of potential current and potential differences in the circuits, and examine behaviors of ohmic resistors and capacitors, comparing values from experiment to values from calculations. Findings: current in two resistor circuit 0.02A, current and potential differences values are the same between calculated and experimental. When a resistor has greater resistance in an RC circuit, the time to capacitor charge and discharge has been increased. Here are some examples of the models. The system is ammeter voltmeter, the surroundings of the circuit, current and potential difference. The first circuit so I use the PHET simulation for everything. The circuit has two batteries, two resistors, two ammeters. The predicted current was 0.020, the actual current was 0.02, and the reverse ammeter is 0.02. Part 2 and 3, open circuit and potential differences. To the right is how I set up the lab, and then to the left is the potential differences I found at each point, as shown below. And A to B is 3, and so on. The important thing to understand from this is that these values support the loop rule because all of them add up to 0 volts when you add them all together. Part 4, parallel circuit. Parallel circuit with a 100 ohm resistor. Current increased from 0.02 in part 1 to be 0.06 in part 4. This is backed up by using the formula for a parallel circuit to solve for current in part 4. And this makes sense because of just understanding how series work in parallel, and how that's different. Part 5, finding resistance. Use Ohm's law to calculate resistance. I found resistance of the 47 ohm resistor to be 47 ohms, resistance of a 100 ohm resistor to be 100 ohms, resistance of wire is 0, resistance of ammeter to be 0. The formula is to the right. Part 6, RC circuit. Construct an RC circuit, 10 ohm resistor, 200 mF capacitor, 9 volt battery. Measure the time to charge and discharge the capacitor. I got that as 7.7 and 20.3 seconds respectively. More resistance means a greater time for potential difference to decrease, which means that it takes longer for amount of time for current to reach 0. This is my round trip potential plot with a 9 volt battery, 30 ohm light bulb, and 200 mF capacitor, and record the potential difference change every second for 20 seconds. Plot ln of V over V0 versus time. The slope of the plot is -1 over RC. So that means that RC equals 6.289 seconds using the slope I got from this graph. The sources of error. Lab was done in PHET. Precision of ammeter, rounding earlier in calculations, human error. Resistance in ammeters and wires was disregarded, and resistance values calculated are greater than values found in PHET. And if we use an actual ammeter, the ammeter has a resistance, though the resistance is very small. The current in the circuit would have decreased slightly, and thus the overall experiment would have been affected. If we were doing this in real life and we hooked up a battery to charge a real capacitor with no resistor in the circuit, the model would show reaching full charge instantaneously, while this would not happen in real life because the wires have resistance and would thus increase the time for the capacitor to reach full charge.